Hello, sixth graders, it's Mrs. Hebert. Today we are going to be working on lesson 13.4, which is the area of polygons. So if you would add that to your table of contents and then set up your page to look like this with just 3 boxes, one wide box at the top and then 2 long narrow boxes at the bottom. In box number 1, you just need to write this information down. And it says you can find the area of polygons by breaking the polygons into smaller shapes. Then apply the formulas you already know. So that's what we're going to be doing. Okay, in box number 2, go ahead and draw this polygon and label it accordingly with the different measurements. And then we're going to, for step number 1, write these words. Draw a line to divide the polygon into a rectangle and a triangle. So I'm looking at this shape and I'm saying, what familiar shapes can I find in this polygon? And in this case, it's pretty easy. It's a rectangle and a triangle. So I'm going to use a red dotted line to break this shape up into a rectangle and a triangle. Then, for step number 2, go ahead and write the step, find the area of the rectangle. So I'll start by finding the area of the rectangle, and it's pretty easy because the area for a rectangle is just base times height. So in this case, it's 16 times 7, and if you do the math, that gives you 112 square centimeters because it is area. Then I will find the area of the triangle. Now, remember that on the triangle, the base and the height are going to be perpendicular. Perpendicular means they form a right angle, the base and height. So that's how you can figure out the base and height. So when I look at this triangle, the only place where the 2 lines make a perpendicular line are right here. So that gives me a base and a height. So I just have to figure out what the base and height will be. So on my triangle, I know that the base is the formula is going to be area equals 1/2 the base times height, because a triangle is basically half of a rectangle, and that's why our formula is 1/2 base times height. So in this case, if I look at my rectangle and I say, okay, the bottom of my rectangle is 16 centimeters, and I'll underline that. Opposite sides of rectangles are equal, and so if the bottom is 16 centimeters, then the top, if I were to look at the whole line, would also be 16 centimeters. However, I know that the right-hand side over here is 8 centimeters. So I know I can figure out the rest of the top of my rectangle, because I can take the whole length of the base, which is 16 centimeters, subtract 8, and that gives me the remaining part of that rectangle as 8 centimeters. So I just did 16 minus 8, and that gives me 8 centimeters. Then I can do the same thing on this side over here, and I can say the whole length is 13 centimeters minus the rectangle section, which is 7 centimeters, because opposite sides of rectangles are equal. So I'm going to say 13 minus 7, and that gives me 6 centimeters. So now I figured out my base and my height. So now I can plug it into my formula, and I can say the area equals 1/2 times the base, which can be either one. And so I'll say 8 times the height, which is 6, which equals 1/2 times 8, which is 4 times 6, which gives me 24 square centimeters. That's a 4, by the way. So now I have 112 square centimeters for the area of the rectangle, 24 square centimeters for the area of the triangle. So step 4 is to add the areas of the triangle and rectangle, and that will give me my total area. So 112 plus 24, I get 136 square centimeters. And that is my total area. Okay, in box number 3, draw this polygon that looks basically like an L shape and label it accordingly. And we're going to use a different method to find the area of this polygon. This time, instead of breaking the shape into a rectangle and a square, or two rectangles, we're going to create an imaginary shape by drawing some imaginary lines. So step 1 is to draw a line to the right edge of the polygon to form an imaginary square with a side length of 60 feet, and then find the area of the square. So with my red, I am going to draw an imaginary line each way to create a large square, which I will highlight in blue. And I know that all 4 sides of a square are equal, so I know that all 4 sides, each side should be 60 feet total. I'm going to use that to help me. So I can find the area of my large square by either saying length times width or base times height, which is 60 times 60, or for squares you can also just square one side, which is 60 squared. Either way, you're going to get 360 square feet. Then I'm going to find the area of the missing piece. The missing piece is this imaginary section that we created with the dotted red lines. So I know that at the top, if the left-hand side is 20 feet, this other side of the top has to be 40 feet because I know the total distance is 60 feet because all 4 sides of my square have to be 60 feet. On the right-hand side, I know that if the bottom part is 30 feet, then the top part has to be 30 feet because 30 plus 30 equals 60. So now I'm going to use that information. I'm going to say, okay, I know that my base of my, I'm going to find the area of my missing piece, of that little piece. So I'm going to take my base at 30 and my height at 40, 30 feet times 40 feet. And so then my area equals 30 times 40, which gives me 120 square feet. So that's the area of my little piece, my imaginary piece. Then I'm going to take the big piece, the square, and the area was 360 square feet. I'm going to subtract the missing piece area from that, which is 120, and then that gives me 240 square feet, and that is the area of my polygon. That is the area that I started with originally, which is, I'm going to color into blue here. So the area of this blue section is 240 square feet. And so that's another way to do it. Okay, when you finish, your journal, your math notebook, should look something like this. And then we'll do some more examples in class of some other shapes. But basically what you do is you look at a polygon and you try to break it into known shapes, or you create known shapes with imaginary lines to help you figure out the area. And so we'll be practicing more of that in class. And that's it. We're done. Good job.